gonna walk.
Yeah, I was like, we're not having these, so when it goes into zero,
Okay, no one talk, no one talk. Okay, so part of the reason we're doing this, I pay you points for participation today, because I really want to get a better feel for the whole room. So we'll do this periodically. Again, when you look at an AP question, if your first reaction is I don't know what to do, it's totally normal, you don't worry about it. But as you read the question, you do have to start thinking of things that you can write down. So somebody just raise your hand, offer something we can write down that might at least kind of push us in the right direction. And again, raise your hand, I'll pay for more than one person, so who has an idea of what we can write down? So if your hand is raised, you get one, and then we'll go to Brinley for two.
I can plug two in for X.
So Brinley's thinking you want to plug in 2 for X, are you saying?
On the, like, for the first one, I just plugged in 2 for like the 2 minus X part to see if like the inequality is true.
So Brinley's thought was this. She said, I'm going to take 2, and you're plugging it in here. Is that what you said?
Yeah.
Okay. Not a bad idea. We need to have a reason why we're doing it. Just got to make sure we have a reason, otherwise you're going to have trouble on future questions. So who has a reason why we would think to do that? Let's go, your hand is raised 1, go to Kenna for 2.
So it asks you for what values is X of X not continuous. If you look at the table, you can tell you have a value of 0, a value of 1, and a value of 2. So the best way to see all of those is to write a table.
Good call. So make a table and actually give 3 to Kenna. That was a really good answer. Kenna says we need to focus on 0, 1, and 2. So we're going to put those in here. Okay. I need a little more detail. Like, you've got to make sure this makes perfect sense. So a little more detail. Why is focusing on, actually, like, why is 0, 1, and 2 important? Oh, no, come on. Why are we focusing on 0, 1, and 2? So 1, if your hand is raised, we'll go to Dawson. So
You're trying to find where the function, like, if it's where continuous, where the holes are in it, and that graph. So those are the numbers that you have, and you find where the holes are between the numbers.
good answer. Somebody elaborate on that. Like, again, in more detail. Why are these the important values of X? Let's go, Dave.
Those are the remaining points where they could do the piecewise function.
That's getting really good. So it's a piecewise function. If we're looking to make sure something is continuous, what should we need to remember we can't have any holes, we can't have any vertical asymptotes, we can't have any jumps. So let's see, continuous. So no holes, no vertical asymptotes, no jumps. Right now, Nate was focused on this one because he said, hey, it's a piecewise function. Only piecewise functions can have jumps, and the jumps can only occur at X values where you stop using one formula and start using another. Somebody, hand please. Why did we not worry about holes and vertical asymptotes? All who know. Why are we not worried about holes and vertical asymptotes? All who know. So point, we'll pick on Emily for 2.
Because those are only when it's like a rational function with like a numerator and
Nicely done. Unless the formula has a denominator that can become 0, you can't have a whole or vertical asymptote. So jump is the only thing we are concerned about. So, jumps always occur from like one X coordinate to another. So we've got 3 X coordinates on the board. Do we need to have other X coordinates listed on the board? Hands, who knows? We have other X coordinates listed. So you get 1 point for your hand, and we'll call it Reagan for 2.
So don't you want to get like the values that are really, really close to each? So you want to be like a little less than 2, a little more than 0, to make sure that it's continuous on those points too.
No, really good answer. Look, hey, everyone listen. really good answer. Follow-up question though, follow-up question. Okay, for the function to be continuous at x equals 0, you all need to have this memorized as well. So if f of x is continuous at x equals 0, then what belongs here? Like what must be true to guarantee that the function is continuous at x equals 0? Like you need to have this little statement memorized. All come on. You have this one memorized. Let's go Chelsea in the back.
Is it clear there has to be a point at x is 0?
There does. So how do we indicate symbolically that there is a value of the function at x equals 0? Hands, come on. How do we indicate that? Let's go here and point if your hand is raised, and 2 for Nathan.
Is it, you have to, or if it's slightly less than 0 and slightly more than 0, don't they have to equal each other in that case?
True. In fact, look at my hand again. Look at my hand. So I'll do this all year long. If we're talking about x equals 0, this is the point where x equals 0. Got it? Okay, whatever this y coordinate is, the way we describe that y coordinate, we call it f of 0. So that's got to be some value that we know. And then that value has to be exactly the same, or infinitesimally close, to whatever this y coordinate is and whatever this y coordinate is. But we have a mathematical way of describing this value and a way of describing this value. Who knows what I'm talking about? Raise your hand. Come on. What am I talking about? Okay, once again, so I don't have to keep saying it. If your hand's raised, you get 1. If I call on you, you get 2. So Laura.
The limit of x equals to x is 0,
Keep going, Laura.
and then the other one is the limit of the x approaching a little more than 0.
Nicely done. So that matches up perfectly with what we wrote here. To check all 3 of them. It's very good. Questions. That's what Reagan was saying. Somebody asked why these are on the table. Okay, look at me. Oh, David, please, question.
Sorry, no, why is the f of equals 0 in the middle there? Sorry, the f of 0.
This one here.
Why is that in the middle? Yeah.
So again, for the function to be continuous at this x coordinate, which I'm representing by this point, you have to have all 3. You have to have all 3. The value, the y coordinate here, which is called f of 0, has to match these 2 values. Cool. 2 for David, good question. Okay, flashcards, look. Okay, you've had your first kind of practice test in this class. It was just a homework assignment. But basically, this was like a practice test. This is what it's going to feel like when you take the test I give you in a couple of weeks. All brand new problems. You're going to read a problem. It's normal to not know what to do. You've got to figure it out. Okay. One of the keys to being able to look at something you don't know how to do and then figure it out is having your memory good enough that these little ideas just come to mind. Because you won't have anyone to give you a hint. So you guys have to look at the problem and go, okay, what do I remember about these ideas? There are a few key things that if we put them on a flashcard, it'll make those memories a lot more permanent. So I don't force anybody to do flashcards, but if you'd like to, you're welcome to use these. There's 1 deck per table. When they're gone, we just have a whole other box in the back. If we need more, we'll buy another case. So anyway, what I would have on a flashcard is this. I would have written down this part right here. I would say, I'd say if f of x is continuous, then I put ... to just kind of prompt me to flip the card over. Then the back side of the card is going to say this, right here. Because that's what I need to be remembering. So if you want to make a flashcard for that, please do. If you don't, it's totally up to you. But the memories really do have to come to mind quickly. So I can write that down. And then once you have a good pile of flashcards, you need to go through them every day to make sure the memory is very fresh. Don't just wait before the day before the test. The memory won't be permanent enough. probably add to this same card. So on the front it just says if f of x is continuous, then on the back it says this. I'd probably just write also no folds, jumps for glass enclosures. That goes with the same idea. So. Cool. Question. Awesome. There's actually a reason, okay, now in this problem, to prove continuity, we would need to find all three. In this particular problem, we can take a bit of a shortcut. One of these three we actually don't need to test. But you need to know the reason why we don't need to test it. So of these three, which one can we ignore and why? Who knows? It's one if you raise your hand and two if I call on you. Try to be as best I can at kind of alternate. Ethan in the back.
Ignore the zero positive because the second part of the piecewise function says that x can either equal 0 or be a little greater, so you should just use 0 because it can't equal 0.
Nicely done. So when I use this x coordinate, it goes into this formula. If I use this x coordinate, it goes into the same formula. The jumps only occur when you're going from one formula to another. So we don't need to check the same formula twice. So we're good there, even though this would be required if we were proving continuity. Questions? Somebody, oh, please, Laura.
Could you use just 0 instead? Like, does it matter if it's 0 or 0? So it'll
Oh, you really do need to think of it as being a little bit less than 0, because that's the value that goes into this formula.
Yeah.
And then 0 exactly goes into this one. Like, I would ignore this one.
Okay.
Like, that's exactly what, I'm not answering your question. Keep talking, Laura.
I'm just saying, could you ignore just the normal 0 and just use 0 just a little over 0?
Oh, gotcha.
Is it better to just?
Better to use 0. Because what you're looking for, it's a really good question, 2 points, Laura. You're looking for x to make an infinitesimal change. And so from 0 minus to 0, we think of that as being an infinitesimal change in x. If we went from 0 minus to 0 plus, that's actually more than an infinitesimal change. That could cause a mistake. So I make the tiny change in x, and I test to see if there's a similar tiny change in y. Perfect. Somebody go from there, hands. What do we do now? Go. Thank you, sorry.
You're good. So, you also need to do a little less than 1 and a little less than 2.
Oh, nicely done.
And
Hold on.
then,
You get that written down. It's more for Blake, but she gets the third point for me messing up on the name. So Blakely says we need to do this. And she said this one as well.
and then you just
So somebody just follow Blakely. What do you do? Well, go here, Carter.
Start bringing them in.
So look to right, Sean.
So for the first one, the sign of 0, the negative, which is 0.
So the sign of 0 is exactly 0, so this should be really close to 0. Somebody else here? 2 for Carter. Let's go to the front, please. And Y. 0 squared is exactly 0. Oh, so somebody commented on what we observed here. So he's the link.
So they're the same numbers, that means there's not a jump there.
Very good.
Against that point.
So there's not a jump at x equals 0. Question? So I just gotta know if we need to keep going if you're getting bored. So if you want me to keep going, just gotta wave like this so I can see. Okay, cool. Somebody keep talking. Let's go, Dawson.
For the 1 minus 1.
Curve one. So that's gonna be really close to 1. Won't be exact, but pretty close. Keep talking, Dawson.
Minus 1.
So that's gonna be exactly 1. So no jump there. Anybody else? Let's go here, Nathan.
Then you plug 2 minus in to the same equation and get 0.
2 minus 2, yeah, get really close. Or as close as 0 is good. Go.
And then you plug 2 in that last one, and then you get negative 1. So you know
Follow-up question. David, please.
Why is that suddenly the answer then?
So I'll ask you a couple questions so it becomes more clear to you. So what's the goal of the problem? Find out what's not continuous. So we made the flashcard. Now somebody help David. 2 for David. Somebody jump in here. So follow my logic. So I'm trying to find out where the function's not continuous.
Wait, no,
Oh, no,
the-
please.
The 2 minus approximately equals 0, so there's a jump between the 2 minus the 2.
Oh, very good. Yeah, so
Okay.
because there's a jump, my bad. So because there's a jump between 2 minus and 2, the convention is just to declare the jump to be at 2.
Yeah,
So this is where is the function not continuous? It's at 2.
yeah, that makes sense.
Okay, very good. There we go. All right, please.
So I understand like why it's not continuous at 2. How come earlier in the problem we didn't have to worry about holes or bird box?
Gotcha. 2 points for a good question. Because you have to know the answer to that. All we know. Nice. The question was, why did we not have to worry about the vertical velocity function holes?
Oh, right.
Perfect. All we know. Bailey?
Because there's no like denominators and numerators and numbers.
Yeah, this is how we calculate y coordinates. And there's no way to calculate a y coordinate that will end up being divided by 0. So, does that make sense? Yeah. Good question. Questions? Give me some feedback. So this means, and I'll pay you for voting, so this means I'm still like, none of this makes any sense at all. Just be honest. Just like, no, that's solid. I feel really good about everything we talked about. So show me something in between if you're kind of in between this. Okay, if you're a little bit fuzzy, there's still a few people. You have got to find time to be here like 7 in the morning or after school for a while. Calculus, I'm really serious about this. Look, calculus is like learning a difficult foreign language. And if you start to lose track of the meaning of words, as we start using those words, you can't figure out what the new words mean. Okay? So it's really like learning a difficult foreign language. You've got to make sense of it little by little. So if it's still a challenge, you got to come talk to me. So, next one, cool. 29. 30. All right, the point game continues. So we read the problem. If we don't know what to do, that's okay. But we do have to be able to find ways to write something down. You can't just stare at the problem. So looking for heads. Awesome. So again, point if your hand is raised, we'll call on Hannah for 2.
Just like simplify it.
Tell me what to do, Hannah.
So in the numerator, you can factor it out. So it's going to be x plus 2 and x minus 2.
Cool. Pause right there for 1 second. I need a little space to work, so I'm just going to kind of cross this off. Actually, I think what I'll do instead, let's do this instead. Let's just go to a new page. So, hold on a second. This is what I want. So x squared minus 4x plus 2. So Hannah said we have this function. This is problem number 30. The function is x squared minus 4 divided by x plus 2. Is that correct? Thank you. Hannah said that can factor into x minus 2, and her choice to factor is a really good choice. Even if by chance you don't know why you're factoring, it's still a smart thing to do on the AP test. I've solved a lot of AP questions myself by saying, I'm not sure this will help, but I know it's not illegal, so I'm just going to do it and see if it leads to something. Get used to that. That's a normal, real-life solution. Somebody talk now. What do you want to do? There we go. Somebody. Let's go, Ethan.
I would split it up like x minus 2 over 1 and x minus 2 over 2.
Nicely done. 1 if your hand was raised, 2 if your name is Ethan Morgan. Somebody comment from there. Hands, please. Hands, comment. Somebody new, sorry. Probably don't want to read. Let's go here. Brianna.
Then I plugged in a negative 2 into all different sides. And
Oh, right, so you did this kind of thing again. where you said, we'll plug in a little less than -2 and a little more than -2. Is that correct?
I actually didn't do that, I just did the negative.
Just -2, exactly. That's fine, no. Stay with it. So let's do that. So what happened when you plugged in just -2, Brianna?
Well, on the left, the x minus 2 over 1 are just
True, and what does this become if we plug in -2 here and here?
1.
So small mistake, no worries, but extra point because you're willing to talk about it. Actually, give yourself 2 more points. The key is, you have to remember that this, okay, how do I say it? It doesn't matter what value x has, this will always equal 1, because something divided by itself is always equal to 1. But there is an exception you have to remember. So it hands up if you remember the exception. What is the only x value for which this doesn't equal 1? It's super important to remember the exception. So Stephen.
-2.
-2. So Stephen, if I actually plug in -2, what does this actually become?
0.
Not quite, but we're getting close now. It's okay. So let's go to Katie.
Undefined.
Undefined. Makes sense. Because you get -2 plus 2, which is 0, divided by 0, that's undefined. So really, when you plug in -2, the formula doesn't give you anything. You don't get any value. Are you with me? But the question says, if this is our function, and you can't plug in -2 into this function, then you have to define f of -2 some other way. You just have to tell them what's the y-coordinate, because the function won't find the y-coordinate. We're supposed to be able to find a y-coordinate here, but we're also supposed to make sure the function is continuous. So suggestions on what we can do now. Hands, come on. What can we do this time? So maybe it's a chance here. My apologies if I do not fail to call you at least once and try hard to get everybody. Let's go Brinley.
Then what did you just plug in, well, that would go back to 1, right? Or you're talking about that, and I just did it right.
The trouble is this, you're doing great, Billy. The trouble is, you're supposed to find a function that is continuous. But we have a problem. When you plug in -2, the formula doesn't provide a y-coordinate. So that's not going to be a continuous function unless we can come up with a y-coordinate. So we're kind of wondering what to do now. So we help her, don't worry. You're okay, 2 points for that. It's all a matter of you just got to keep talking about it. Eventually you kind of stumble across the answer. So Connor.
You can plug in a little less than -2 and a little more.
Plug in a little less than -2 and a little bit more. And what do I get that time? Somebody else. Hands, come on, what do we get if we plug in those? Keep thinking, stay with me. The more you stay with me, the more you're really making sense of the ideas. Let's go to Keston.
Can I just plug it into that and wait, I have to solve it?
So we're going to plug it in here.
Yeah.
The thing, though, is that makes this a lot easier is, what is this always equal to?
Undefined. Well, no.
It's actually most of the time equal to 1. It's only if we plug in x equal -2 that this becomes
Yeah.
undefined. So we're plugging in not x equal -2.
Yeah, so would it end up equaling like slightly less than 0 or?
So this will be really close to 0, but not quite.
Yeah.
Key question is this. Will this number be the same as this number, or will they be different values?
The same.
It'll be exactly the same. Take something divided by itself, what do you get?
1.
1. So, for this example, this becomes 1.
Okay.
So that's easy. 1 multiplied by what will this become?
0 over 1.
No, because it's -2 minus 2.
-4.
There we go. So this is really close to -4. Good question. Please. So are you comfortable, Suganda, that 2 points for a good question? Are you comfortable that this is going to become exactly 1? So what? So we're plugging close to -2 minus 2. What's -2 minus 2? Close to -4. Should we now? What about this one? Somebody, come on, hands. Come on, you gotta speak up just a little bit. Just so hard to get balance on the answering. Aaron?
Basically the same thing, just a little less negative, it's really close to the same.
Really close to -4. So if f of x is supposed to be a continuous function, what value has to go here? Just say it. -4. So this value has to be -4. Question? Awesome, next one. Okay, 32. Looking for hands. Oh, let me explain one thing first, sorry. I've noticed after teaching AP Calculus now this is my 11th year, a lot of students come into my class with the wrong idea about what the equal sign means. They mentally think of the equal sign as being an arrow that says, hey, the answer comes here. Okay, don't do that in this box. Equal means same as. You're trying to find something that is the same as. So when you look at this statement right here, don't think to yourself, see, the limit as x approaches a of f of x is this. And that's true, but it can kind of mess you up. Better to think, oh, let's go figure out what this is and see if it's the same as this one. That's how you answer this type of question. So look for hands. What do we do? Just got to start writing something. Everybody a chance to think. Let's go Chelsea in the back.
So I found the limit of A and then the limit of B.
Nice. So Chelsea says, let's go find each limit individually. So how do we do that? Come on, hands. How do we do that? How do we find each individual limit? Holly.
Look at the graph and go slightly to the left of A and slightly to the right.
Yeah, that's perfect. So I look at the graph and I say, just a little bit to the left of A, the point would be located here. A little bit to the right of A, the point would be located here. Those two y coordinates, Holly, are both close to what y value? 2. So I just figured out this. The limit as x approaches A from the left, that's equal to 2. The limit as x approaches A from the right, that's also equal to 2. Therefore, the limit as x approaches A in general is equal to 2. Question? Now what do we do? Hands, come on. No. So Rachel?
You find the limit for B.
So we need to find the limit for B. Somebody talk about how to do that. Find the limit for B. Let's go, Kate.
Use a little bit to the left of B and a little bit to the right of B.
So from here to the left, we're going to go a little bit to the right. Start writing these down. So see the limit as x approaches B of the left. So you're going to, I want everyone in the room to vote on this one. Is the answer to this question 0, 1, 2, or 3? Show me the answer to this one here. The limit as x approaches B from the left. Is that value 0, 1, 2, or 3? Show me your vote. You wait for 4. Okay, if you voted, you give yourself a point. If you voted this, you give yourself 2 points. Okay, this is the point where the x coordinate is just slightly less than b, and the y coordinate happens to be just a little bit more than 2. So the limit, as we get an x coordinate really, really close to b, will produce a y coordinate that's extremely close to 2. Okay, when you're learning new concepts, it's totally normal to sometimes misread, misthink, or whatever, get it wrong. then once you hear the correct answer, it makes sense to you. That's fine, that's just part of learning. If, however, this does not make sense, you need to be doing something at this point, which is a code for you need to raise your hand and talk. You don't have to have a question, but you need to talk. Anybody? Awesome, do the next one. So we go limits as x approaches from the right. Vote. 0, 1, 2, 3. Show me. This is better now. I don't got anybody missing at this time. Pretty good. This means you get 2 points. If you voted, you get 1. This is the point right here where the x-coordinate is slightly more than b, and the y-coordinate is slightly more than 1. So this limit is exactly 1. Just raise your hand if you know the answer to this question now, and you know why. Hands up, who knows the answer to that one? Come on, show me, show me. Who knows the answer to that one? Let's go, Kate. And why?
Because the limits are different from the left and right.
Perfect. Left and right limits are different, therefore the overall limit is non-existent. Question. So show me, this means true, this means false. True or false? Come on, show me. Oh, my bad. True, false. True, false. This one. So if you're doing this, give yourself 2 more tickets. Not tickets, sorry, points. Wrong word. Wrong word. Yeah, Dawson's like stoked. He's like, yeah. It's great, man. Take a little vacation over the next couple weeks. Questions? Good? Awesome. We're pretty much done now. Skip that one for a minute. Do you have any further questions on this problem? So that is the correct answer. Awesome. Next one. Cool.
I was 30.
Gosh. We'll resume. Okay, 35. I'm actually not going to do 35 because it's exactly the same question that was on the quiz, essentially. The only difference on the quiz is the numerator was 1. If x is approaching 1, the numerator becomes 1, so it's the same question. If that one's bothering you still, you've got to come talk to me. $36, look for hands. For hands on 36. Hands on 36. There we go. Let's go to Shelby Nichols.
So do you make a table?
Table's a good choice. Let me just catch up to you, Shelby. Hold on. So I'm going to cross these off for a second just to illustrate that I'm just using this space up here. So I make a table. Just to share all the points. Somebody just build on what Shelby suggested. Just go from there. Just follow her logic. Come on. Build on that. So Kenneth?
You gotta take, you gotta figure out what x is. So you gotta plug in if one is getting, x is getting close to 1, and you can't use exactly 1, so you take a little bit less than 1.
You mean 2?
Oh, okay.
No, because you were looking here.
Yeah, I was.
Yeah, no worries.
Because you wrote it.
Yeah, that's not your fault.
Yeah, so you're finding the value for 2, but you don't want to plug in exactly 2 because then you don't know
finding a limit. She like hit every key point. It's what I, okay, put down 4. I'm serious. Put down 5. Okay. I'm kind of excited. Stop myself from saying, yeah, 5 is good. Okay.
Oh my gosh.
Listen. No, really. Okay. That's what I mean by understanding a concept. She's not remembering a problem. She's saying what you'll need to say no matter what the problem is. She said, okay, when I go to find a limit, I cannot pay attention to when x is equal to 2. That's important, because people make that mistake often. I've got to pay attention to when x is a little less and a little more. It seems like a simple idea, but that's crucial, like for any limit problem. So hands, build on that. Come on. Now what do you do? Come on. What do we do now? Keston.
Do you plug in the 2?
Just tell me what to
Yeah,
write.
so you have to like factor it and then plug in the 2.
Oh, so you're looking here as well. We're working on this one still. I just needed some space to write it out, so no worries.
Oh, yeah.
Cross out this
I
is
was
just
looking at.
Sorry about that. That was
I
better.
was looking at 37.
Yeah, sorry.
But it's
Down
okay.
here.
I was looking at that.
So hey, so first thing, 3 for Kesta, because she is correct. We are solving this one. You definitely want to factor it, for sure. Definitely want to factor. Help us, Dawson.
So now you gotta start plugging numbers into the right formulas.
Tell me what to write then.
So for natural log, and then plug in a little bit less than
Well done. Pause there. Somebody else pick it up from there. Come on, hands. Come on. Let's go test this.
You would then plug in a little bit more than 2, and that is using the bottom part of the piecewise, so it's 2 plus and then natural log.
Nice. It does. 2 plus squared. Ln of 2. Good job, Chelsea. Now what? Chelsea.
Did you know that like the multi-times have the L and 2? You know that they're not equal because the other one has the.
So the limit from the left does not match the limit from the right. Conclusion is the overall limit is non-existent. What's that? Oh, I got you. Yeah, I got you. I know what you mean.
That was kind of like plugging into the
Gotcha.
natural log.
Yeah, let's do a little game here. Hey, look up. Hey, Dawson really did make a really good comment too for Dawson. All of you can pick up a bunch of points here. Get ready. Answer this, please. Just raise your hand if you know. Just raise your hand if you know the answer to that. All you know, okay, everybody. So let's pick up Hannah.
1.
So 2 for Hannah, 1 for the rest if you had it right. This is kind of easy, so we'll just pay. No, raise your hand. Who's that one? Suganda? So how many had it? Show me that. 2 points for everybody who had it right. It's a pretty exciting game. Kenzie. So 3 points if you got that one right. 3 points if you got that one right.
Ln of 21.
No 1, 3 points?
Ln of
I'm setting up for a joke here. Ready?
Do natural log.
Oh, really?
Last year's the last one, too.
You know what's the answer to that one?
Oh, no.
Quickly! Yeah. How many got it right? Yeah, 4 points. Good job. Okay. I don't have the heart to do this one.
Ln E of 55.
All right, it's pretty good. I think that last period, I was pretty proud of myself. Hey, look up. It's a spontaneous joke. That's pretty good. So Dawson's question is, yeah, you don't have to worry about knowing, like they expect you to know this. The natural log of, e to the first or the natural log of e. But they don't, so all of these you would be expected to know. But you don't have to do anything with the natural log of 2. Just leave it as natural log of 2. The key is what, I forgot who was helping me, I apologize, but the key is the person who explained, who helped me with this, who said it really well. There, Tessa. She explained really well. These two values are essentially the same. They're both natural log of 2, or at least really close. But this one's multiplied by 4. So they can't be the same. So, yeah. Other questions? Sweet. Moving on. 37. Let's do that. So, new page here. Is it a squared minus x squared, x squared thing? Did I write it down correctly?
Yeah, you're good.
Thank you. Show your hands if you can think of something to do. Because remember, you're getting used to the idea that you don't have to know how to do everything, but you got to think of something. Guess we're back to your big moment. Go.
Yeah, you factor.
Nice. Somebody back here for me. It is very wise to leave the top alone. It's very wise to not factor it. So somebody else. Yeah, because the bottom's gonna have a matching factor. There we go. Let's go, Emily.
So from the bottom is the x squared minus a squared times x squared plus a squared.
Nicely done.
Woo.
Somebody else. Here we go. Come on. Come on. What else? What else? Brianna. So go to right.
X squared minus a squared minus a squared on some x squared. Oh, 1 over x.
Work. Okay, question for the whole room. Okay, when you see this, you need to remember. If you need a flashcard to remember it, make a flashcard. If you're not sure what to put on the flashcard, just raise your hand and say, hey, Mr. Smith, what should I put on the flashcard? I'll help you. I just am really, like, I hate helping when you don't need help. So I just like you to ask. Here, okay, we can plug in a lot of different values for x. What will this always equal most of the time? 1. What is the only, actually there's 2 exceptions, hence please notice that both exceptions. There are 2 different values of x for which this doesn't equal 1. Usually we think of there being a single exception, this time there's 2. So the 2 exceptions, 2 values of x which cause this to not equal 1. What are those 2 values, Mary?
Negative a and a.
Nicely done. Because Mary, if you take a negative a and square it, what do you get? A squared. So whether the a is negative or positive, it doesn't matter because we're squaring it. So if x is equal to negative a or x is equal to positive a, this will become undefined. Please, oh, thank you. Let's do this. I gotta think for a second what would help. Because I'm always thinking, Dawson's like, what kind of memory do I want to embed in your head? That's right. All right. So let's do this. I think I would just say on one side of the flashcard, use this as an example. I think the example will be good enough to remind you on future problems. So we'll say x squared minus a squared divided by x squared minus a squared is equal to question mark. So that's on one side of the card. And then you flip it over and you have written down 1 unless x is equal to negative a or x is equal to positive a. And then would be undefined. I think that's enough to remind you of the idea, to make that memory permanent. Custom.
I just have a question. What is A?
YA.
Yeah.
So if we plug in A exactly, we get this. A takes the place of X.
Oh, so when you subtract them, okay, that makes sense.
Right, so you end up with a 0 divided by 0, hence undefined.
Okay, cool.
Okay, look up. Oh, question, please. For this class, really, it's good enough to simply memorize that when they ask for the value of a function, you use the word undefined. If they ask for the limit, then it doesn't, you can't find one, we say it does not exist. That's good enough for this one. Okay, determined by the limit as x approaches a. We're ready to do it.
Okay.
Like it's all set up perfectly now. Hands, what do I do next? Come on, show me. What do you do next to find this limit? Let's go Brindley.
I'm plugging A for X.
Okay, 2 for Brindley, but that's a big mistake. Don't do that. No worries. Mistakes are as good as right answers.
I asked in Calc Lab, and that's what I was taught.
Oh, really?
Today.
Oh, interesting. Yeah, I would say don't ever do that. I'm not gonna change. Because I think it's really important to it's what I paid Kenneth 5 points for. When you're finding a limit, we're not ever plugging in exactly A.
Well, I mean like the negative. and-
Yeah, there you go. Sorry, my bad.
Okay.
Yeah, just want to make sure you're clear on that we're not plugging in A, we're plugging in a little more, a little less. You got it?
Yeah.
Cool. So, okay, that's what we just put on the flashcard. If you're plugging a little more, a little less than A, what's this going to equal? 1. So that's easy. So if you're plugging close to A here, let's see, that's going to be close to A squared. Plus A squared is going to be 2A squared. So we're getting close to 1 over 2A squared.
Perfect. The answer.
I never worry about the letter answers. I just want to make sure we figure it out. I can find the letter answers.
So,
Is that right?
what was the point of the negative?
Oh, gosh, you mistake.
It's just that two.
Look up, please, look up. The point is, oh, here it is. Here's why. You don't actually use it. You're correct. They put that on there so that when you find this as the answer, you don't go to yourself, wait a minute, this doesn't work. If A is equal to 0, this is undefined. So they can't let A be 0. That's how. And you're right, we didn't actually use it in the problems.
I know the factors that you plug into it.
It's not really meant to be a distraction. It's really meant to be, they're covering themselves. Like somebody, I probably wouldn't have noticed, I'll be honest. But some students would. They'd say, hey, wait a minute. This problem is not a problem because you can't have A be 0. They didn't tell me that. So. Question, please, go.
Oh, so they're running.
Okay, good work. All right. Pretty good. Okay, 38. Okay, you need a flashcard that says this. You need a flashcard that says, yeah, F has
42 and 42.
horizontal asymptote at y equal 2. Flip the card over, it says, then a limit as x approaches to, no, sorry, x approaches infinity
I'm not sure why.
of f is 2. You need a flashcard that reminds you of that. And I would add a little picture to my flashcard. It's easier to memorize pictures than it is words. I draw this picture to just remind myself of what we mean by horizontal asymptote. So, okay, horizontal asymptote just means when the x-coordinate gets very, very large, the y-coordinate will become very close to 2. That's the only thing that horizontal asymptote means. To emphasize a key thing, lots of people have the false idea too for lots of people have the false idea that you cannot touch a horizontal asymptote. So I draw this to emphasize that you can touch it an infinite number of times if you want. That's a false notion. It's not true. It's just not true.
I've always seen it like.
Yes.
for-
Yes. So I've actually brought this up with this other teachers, and I've said, hey, we have this problem that all my calc students have this idea that you can't touch a horizontal asymptote. And they all like, okay, we'll keep reminding them that you can, but the trouble is the problems they give you for homework never do this. So I just have to kind of let you know it's okay. Mary?
So, could there ever be a point on the horizontal asymptote?
Lots of them. Oh yeah, lots and lots of points on the horizontal asymptote.
So then what do you
Okay, so hey, so don't think of an asymptote as being the special line that you don't touch. Okay, it's not really the right way to think of it. Okay? Sorry. You can touch horizontal asymptote as many times as you want. You know, look at this. Hey, for a vertical asymptote, it really isn't that you're not touching it per se, because when you look at a graph, oh, that's terrible. When you look at a graph, remember, how's that? When you look at a graph, remember that you're really just looking at lots of points. So if this is the location of the vertical asymptote, prior to the location of the vertical asymptote, I have a whole bunch of points. And they do this. It's not that they're really not touching the line, it's just that they're having y values that get closer and closer to infinity. And then suddenly, at the location of the vertical asymptote, there just isn't a point. So that's why we say it doesn't touch, doesn't cross. I don't like that wording because I don't like to think of a graph as being some sort of line. A graph is a bunch of points. And on this side, the points, of course, aren't touching it because they're over here. On this side, the points aren't touching it either because they're over here. And there's just no point in the middle. So it looks like we don't cross it, and we don't, I guess, but anyway, that's what a vertical asymptote is.
So then, when you do the horizontal asymptote, because I thought asymptote kind of meant that you didn't touch it.
Right, that's the false notion. Keep going.
So then, if there's no point on the vertical asymptote, then how's there a point on the horizontal?
Gotcha. Well said. No, really good. Look at me, look at me, look at me. Okay. Both words are called asymptotes. And there are reasons why they chose them to have the same wording. But for our class, you'll do much better if you don't keep them together. You say, oh, okay, vertical asymptote, that's a discontinuity. And that's when the graph does this. And you know, at the vertical asymptote, there isn't a point. Those things are all true. When you go to horizontal, you remember one thing and one thing only. As x approaches infinity, the y-coordinate gets close to 2. Everything else doesn't matter. That's why when you look at this problem, they do a really good job of tricking everybody who takes calculus. Because they say here, let's draw the picture again. So here's the picture I want you memorizing. You should picture this image when we think of horizontal asymptote. Okay. So the first one says, at x equals 0, does the y-coordinate have to be 2? Doesn't have to be. Can it be? Absolutely can be, doesn't have to be. So this one doesn't have to be true. This says there's not a single, this is what Dawson just asked. There's 1 second there, sorry. There's not a single y-coordinate whose y value will be 2. Look at the picture. Can the y value be 2? As much as you want. Let's go to Aaron first, sorry. Aaron.
So, in a graph like this, would it just keep crossing over forever? Would it like
Very good.
It would just keep going.
It's really easy to create a function that has a horizontal asymptote at 2 that crosses an infinite number of times and never stops crossing. The crossings just get really, 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 really small.
Never going.
Right, so it's like a little above 2, a little below 2, a little above 2, a little below. Just gets really, 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 really close to 2. The bell's gonna ring, I gotta pass out the tickets. F of 2 undefined. So when x is equal to 2, does the y value have to be a no? When x is equal to 2, the y value can be whatever you want it to be. Doesn't really matter. The only one is true, the limit thing. Good. Gonna come to you again. You added your points. And I will just run these here. What you got? Add your points.
I missed my two too. I couldn't try.
If you're wrong, you still get to take it.
Yeah.
You're wrong, you still get to
Try to explain it. I is
8. Motivating you to stay with me. Does that make sense? So are you okay with 8? Okay. That seem fair?
Yeah, totally.
Just making sure. And this pink one may have been just because that was like not prepared that day.
Yeah.
Don't worry about that one yet. The prepared one, same thing. I really want you earning those points, just to make sure you're really with the class. We'll just leave that as a 0 for now.
Okay.
If at the end of the term you don't really have other days where you weren't ready for class, we'll go back and like drop that. Okay. So I'm really more concerned with trends, like just cases where like, okay, you're really never prepared, that sort of thing. So yeah, good job. Okay. Mary.
What times do you do help?
So I need to start texting it out. You have the texting?
Yeah.
Very good. So I'll start sending text message and let you know what I need.
Okay. So like after school today, do you do
For
that?
sure today's fine.
Oh, really? Okay. Cool.
Cool.
Toby
Good job,
Hagerman,
Ethan.
can you please come to the attendance office? Toby Hagerman.